So I'm going to do this Codewars, or attempt to do this Codewars kata, and spend 2 hours on this. If I can't do it, I'm just gonna look at the solution. I'm just wait for the stream so I can mute the... Okay. Grid is a dice game played with 6 sided dice. Your mission, should you choose to accept it, is to score a throw according to these rules. You will always be given an array with 5 6-sided dice values. So each value has a point. A single dice can only be counted once in each row. For example, a given 5 can only count as part of a triplet, contributing to the 500 points. Or as a single 50 points, but not both in the same row. Okay. In some languages, it is possible to mutate the input to the function. This is something that you should never do. If you mutate the input, you will not be able to pass all the tests. So pretty much what I have to do, I think, is according to that table and the given array, give the results, the sum of the points. Alright, I think that's the case. So here there's 3 4s, so it's 400 points. And 2 3s doesn't give any points. So let me think about it. So I think first I need to check for the 3. The instances of 3 times. And then I should probably remove these elements from the array every time I check. So if any of the elements are counted 3 times, it's gonna be a score. So I think I should map first. And then I should probably have a variable to keep track of the instances. I can use the itertools product thing to account for all combinations. I don't remember product. It's kind of hard to really understand how this works. I know it's the Cartesian product, but I always forget exactly what it does. In terms of mathematics, Cartesian product of 2 sets is defined as a set of all ordered pairs where A belongs to A and B belongs to B. Consider the below example for better understanding. Yeah, the problem with this is that it takes 2 values at a time. The above solution can be done by looping, but we will use a special. It's used to find the Cartesian product from the given iterator. Output is lexicographic ordered. Returns the Cartesian product of the provided iterable with itself or the number of times specified by the optional keyword repeat. I don't think I'm gonna use this. So the key thing here is how I'm gonna keep track of all of them. Just see if there's an instance of one of the numbers that happens 3 times. in the most efficient way possible. I can make another variable called r, maybe filter, and then I could do lambda x. Yeah, but if I do x equals x, it's gonna return me the whole thing. That's the problem. And if I check for one at a time, like let's say I do a loop with enumerate and then I keep track of I compare one with the next one, then I'm only comparing two at a time. And if I wanted to do that, it's probably better to use the iter2's product thing. So the question is, how do I compare all of them? Maybe it is better to use the iter2's product. Check for sets of two. Another thing you can do is a dictionary for all the numbers and the points. And maybe it's better to create a dictionary. And then I just make an if statement for each one. I can create 6 different variables and then do 6 different if statements. I think I'm gonna do that, but it's probably not the best way. That's the thing. Yeah, I think I'm gonna make it equal to. I'm not gonna make it equal to the points. I'm gonna make it equal to the count for each one in the beginning, and I'm gonna use this dictionary to loop through the array and see how many instances. Then I can filter the dictionary later and see if there is any value that is 3. If there is a value that is 3, I get the number, and based on the number, I can have another dictionary that gets the points. Yeah, I think that's the best way. Not the best way, but the easiest way that comes to my mind. And there's probably a better way to do this, but. So 1, 2, 3, 4, 5, 6. Oh, I forgot the 0 here. 5, 6. So maybe it's better to use a map instead of a filter. Or it's probably better to loop through dice. Because I'm gonna put a bunch of if conditions. Yeah, then I need to create 6 different variables. Let's think. I'm gonna have to convert into a string. That's probably the best way. So string x, if string x equals to dick. But how do I get the values of the keys? That's the thing. It's probably better to do. Yeah, but if I do an array, then I can't use the count. The only other ones that are not trees is 1 and 5. I'm thinking about the other possible situations where maybe you have two of one and then you have two of the other ones. And in that case, when you don't have three of any of them, it might be better choose another approach in the beginning. So I'm thinking about using different lists and appending to the lists. It's definitely not the best way, probably not the best way, but because then if I had six different lists, I can separate each element into its own list. I think that's the easiest way, probably. Because then you can just measure the length of the list, and if it's equal to 3, the sum has to be 5. The other ones are going to be empty if there are no numbers that are equal to the list. I think I'm going to do that, actually. So list 1. Kind of feels like cheating, but I'm going to see if it works first, and then I think about a different way if I have enough time. So if x equals 1, plus 1 dot appends x. If x, I think I can do a leaf here for all of them. I don't think there are zeros as well. Should dot append x. So 1, 2, 3, 4, 5, 6, 3. And then here I check for the length of the list. And the problem with doing things this way is that I'm gonna have to loop through all of them. So maybe I can create another list and append all of the lists into that list and do the Cartesian product. Maybe I can do the dictionary and then use the nested list with the Cartesian. Do a zip or something like that, get all the products and make the if conditions, and then using the dictionary for the conditions, and then get the sum that way. But it is more complicated. I think the easiest is just figure out how to filter all these lists in an easier way. I can do a nested for loop, and I wonder if I can. Yeah, I probably can't use a string formatting to loop through all of them. So maybe the best way is to append all of them to a different list and then do a nested for loop and loop through all the lists, but it's not the best solution, obviously. But I think I'm just gonna try to see if it works. So all lists dot append is 1. Two, 3, 4, 5, 6. So now I have a nested list here. And for lists, oh, I can't use lists. We're only in all list. Should put NS there. Whatever. And now I filter each one. I don't need to filter actually. I can just get the length. Now I can create a dictionary. I can have the same dictionary here that I did before. And then I can use this dictionary to compare and get the values. I can also do the count of the points by increasing the value in the dictionary. And then doing the sum of the values at the end. Five, 6. So if this goes 3. So since there are no conditions here for when they are bigger than 3, I don't think it matters. It's just gonna be the same. And we're just gonna have to put a bunch of different conditions here. Maybe I can use key. I can use, yeah, I think that's better way than do a bunch of if statements. I can just do enumerate and then I can know which list it is by the number of the index here. Or I can actually put the values here. That seems like a better way, actually. So I take 1 and 5 out of here. Oh, actually, there is one there. Oh, there's all of them, actually. So 3. Okay, so here's 1,000 points. 6 is 600 points. 5 is 500. 400. 300. 200. Yeah, so now each one of them has the value, and then I can do results equals 0. And here is length, I forgot. Then I can do dic results plus equals dic string, okay. And this is gonna cache the value here. I'm gonna add to the result. And then if the list doesn't have a length of 3 or greater, it means that I'm either gonna add 1 or I'm only gonna add if it's 1 or a 5. And I think for each one is, yeah, but I think there's a catch here now that I think about it. Because what if you have 5 5s? That's the thing. So maybe I should do another separate loop to count the ones. Yeah, no, let me think. So I think one thing that I can do is just remove the values. Can only be counted once in each row. For example, a given 5 can only count as part of a triplet contributing to the 500 points, whereas a single 50 points, but not both in the same row. Oh, okay, so that makes things easier actually. Because if they can be counted twice, then I have to do two loops and two loops like this and check each time separately. But since that's the case, I think I can just leave it like this, and then it doesn't matter. And if they are only... so I think I can just do the same condition here. But now I have to filter through the list. That's the problem. Or I can just do, because they're all gonna be the same number, it doesn't matter. Yeah, but I'm probably gonna run out of the index here. So I can just do 0 here. That's probably fine. And hopefully, I think if it is an empty list, it's not gonna break. So if it is 1, results plus equals 100. If this is equal 5, results plus equals 50. Then return results. $50 for the 5 plus 2 times 100. For the ones. Oh, so we do have to count twice. $1,000 for the 3 ones plus 100 for the other one. So it's different than I thought actually. So I think instead of here I can make equal to 3. And on this condition, then another condition for when it's bigger than 3. And then I can just do result minus the length times the number if it is more. So if the length is 4, it's going to be plus equals this and plus equals the length. Here 3. You can do this. And result plus equals length list minus 3. Yeah, but now I should put the condition. That's the thing. Because it has to be times the number. Times. Or maybe I can do... I probably can find a way to just do some mathematical trick. So I don't have to figure out what the number is. So I would multiply this by the element. But yeah, actually it's better to do if this 0. I can do the same thing that I'm doing here. So if the length is 4, it's gonna be 1. If it's 5, it's gonna be 200. And then here I do the same thing, but times 50. And I could just check for the first number because all the numbers are gonna be the same on each list. And then here, I think this part probably works. And now, when they have less than 5 numbers. Yeah, I think I have to do the same thing that I did here. Oh, I can do it to length list times 100 and length list times 50. Yeah, let's see if this works. List index out of range. Line 52. Oh, so yeah, this happens because the list is empty. So if only I do this. So this checks if there is a list, I think. Yeah. So it runs, but it fails in 2 tests. So what's going on here? 300 should equal 400. So it's failing this one. Let me see the points again. So I'm getting 300. Has to be on this one. That is incorrect. Oh, it's probably because of the key. Yeah, because here doesn't have a 0, so you need to do key plus 1. Probably. There we go. Nice. That was a lot easier than I expected, to be honest. But obviously, the solution is probably terrible compared to the ones that people did. You know, at least I'm very happy that I was able to do it. Let me see how much time it took. Oh, half an hour. Interesting. So now let me think. I think I can save the solution on an IDE and try to find an easier one. Or go to the next problem and just look at the solutions from other people. I kind of want to try to use the Tools product thing because I'm not familiar with it. I know how it works, but I never used it, so. Returns the Cartesian product of the provided iterable with itself for the number of times specified by the optional keyword repeat. I'm almost 100% sure that there's gonna be a solution that uses this. It just seems that it's the perfect situation to use it. I just don't know exactly how. I'm gonna learn about those products. Firstly, we import products. Our output is in the order in which we give input, and it prints out all the possible tuples. Right, the only issue is that it's tuples of true. That's the problem. The other thing that it's probably possible to use some mathematical trick here because from 2 to 6 is a multiple of 100, and then when you have only 1 is 100 and 5 is 50. There's probably a way to do some mathematical trick to make the solution a lot better as well. So maybe I can get the quantity using either those products of each one. Maybe I can do a list comprehension with converting to string with the dictionary and using this product to increase the count. Let me see if I have something opened on PyCharm. I think I'm gonna put the solution that I have on PyCharm and then try to do the itertools product one. I think I was analyzing the scikit-learn library last time I used PyCharm. So I probably can put here. It starts here. So I'm gonna erase this. Now let's try again with a different solution. Oh, actually, I'm gonna keep this dictionary because I think I'm gonna use it. So I think, let's say numbers. I think I'm gonna try to use a list comprehension. But the thing is, string x, string y, for xy in letter tools, imports, products, in products, dict. I think I can unpack like this. No, it's not dict, it's dice. It's probably not gonna work, but I just wanna see if, yeah. Invalid syntax. If I do this, probably not gonna work as well. It's quite confusing to the list comprehensions for me in some situations. When I look at the someone else code, it's easy, but to actually do it in the proper way is confusing. I think product is gonna return the list of tuples, but maybe I have to convert to a list. Yeah, here it converts to a list and it gets two arrays. Yeah, I think I'm not understanding it because I probably have to provide two different arrays. That's the thing. No, maybe not. And then I'm not really sure if I should use this thing here as well. It's probably not gonna work like this. It's probably here the mistake, yeah. What if I do this again? Equivalent to an asset for loop. Oh, so maybe I should do. Maybe I should do this. Dick. Or maybe you can use enumerate. But it is equivalent to an asset for loop. I don't think this is gonna work. Yeah, because I don't want the value. I want the key. What if I do just this? Let me see what I get in return. And if I do this, and because I'm unpacking the list, it's probably trying to loop through the numbers. So maybe this is not really useful actually. Yeah. Maybe an easier solution would be to create a dictionary with the count of each one, and another dictionary with the points. And then I just filter through the list and increase the count. And then filter the object or map through the object and get the result that way. I'm just gonna use simple names for just to save time. So here I can use results. But if I filter, maybe I don't need to make it equal to anything. Oh, actually, it's nice here. The thing is, Maybe we can make dictionary true. I can't use enumerate here. That's the thing. Or I can do string x plus equals 1. Yeah, let's see if this works. Picture. What if I do a return? It doesn't work. This is not gonna work probably. Don't think it's gonna work, but it's worth trying. Huh. So maybe I can do if this, then this plus equals 1. Can I do this? I probably can just do like this as well. It's just more confusing if you think about it. Because it's true numbers. Are probably better. Because then I can remove this from here. So maybe if I use map instead of filter, it works. Yeah, because filter, I'm trying to filter the list based on the condition. And if I do this, maybe I can do the other way around. I can map through this and then increase based on the value of the list. But the issue is that I need to get the numbers from the list. I can just loop through the list. I don't need to map this one. If x equals dict x. Oh, actually, no. I can just do this, maybe. Yeah, but then I'm gonna create another list. I can just... I'm gonna do a normal loop, I think. I think the idea is to loop through the list and then increase the values in the dictionary. Yeah, that's probably a much better solution than the other one. Doesn't work, I'm just gonna do a normal for loop. Yeah. Didn't work. I kind of want to figure out or remember how to do this, with a list comprehension. I don't know why this doesn't work. I think it's because of the expression, but I don't remember how to do it. Because there should be a way to do it with a list comprehension. Whatever. Okay, at least this one works. Yeah, so now I can filter the object maybe. Or reduce. Probably reduce is better than filter. Because I want to accumulate a value and not filter. And I have to use functools. Import functools. So I think B is the accumulator and the A is the value. Yeah, but then that's the issue because it's probably not good to do this because I have to do a bunch of if conditions. It's better to do just a standard loop, I think. I can just loop through the items and I get the key value pair for each one. And then I can do the same conditions I did before and increase the result based on the logic of the points from the condition. I think that this is a much better solution than the one I had previously. It probably works as well. Does that reduce lambda? Let me just see what this returns. Hmm. Yeah, I summon the keys, I think. I think I'm just gonna do the standard for loop. Value equals to 3. Yeah, but now, let me think. Oh, I can use the other dictionary to find the points. I can do a result here equals 0. E plus 1. Yeah, now is the question. I can use the... Oh, actually, let me think. Yeah, so the first one is correct. Now I do probably value minus 3. Yeah, I need to do the other if statement. If value equals 1. Yeah, in either case, I'm just gonna go add the other one. Then 3 minus value times 100. And if value is equals 5, times 50. And then I can do else here. So if it's less, then I can do the same if statement here. Yeah, but then the calculation is different. That should be value times 100 and value times 50. And then I return the results. Hmm. So this shoe I'm getting more, and the other one, yeah, I'm getting more on all 3 of them. And it's probably because I'm checking 2 times here. Oh, I'm checking by the value. Oh, but it should be the value because it's the first dictionary. So let me see. So here there's true. Yeah, I think this part is correct. I'm adding the values based on the thing. So here, maybe I'm not understanding what the value is. But I think value is going to be the value of these values here, this dictionary. So if value is equals to 3, result plus equals... Oh, maybe it's the keys that I'm confusing. Oh, but it shouldn't be. Oh, actually, it should be just key here. Probably. Because this time I'm not using the. I'm using the actual keys from the dictionary. But I'm not sure if that's the only thing that is wrong here. So here I'm getting 300s. So it's 3, 1. Oh, it's because the value is 3. Oh, but it shouldn't be, actually. The key should be 3. The value should be 1. That's why it's confusing to do things like this. Yeah, the value is 1. So why I'm getting 300 here? It's probably because I'm summing the other ones. I should be hitting this condition here. But if the value is 1, this should be 0, and this should be 0. And I don't see another way that it gives me 300. So it should be through this here. But it doesn't make sense. I don't understand what's wrong here. 200. Oh, so it's not hitting this condition. So it's the other ones. So there isn't any value that is bigger than 3, so it isn't this one. That should be the else statement here. Oh, it's because I'm making the value, not. It has to be the key here. There we go. Okay, almost. Just failed 3. So it's not printing anything. Should be when it's bigger than. 3 is 5 here. Oh, it's because I'm adding the results here, probably. On top. Or maybe not. 300s. And I'm making 200s. And 300s. So this should make the results plus equals 300 here. Mm. Oops. Oh, so the value is 5. Oh, yeah, it is this one. What if I print this? It is 300. Hmm. Oh, it's probably because I'm decreasing here. That's the thing. Oh, it's because I'm using value and not key. That's probably the mistake. Hmm. Oh, actually here, let me think. It has to be a value actually. No, it checks for the key. If it's one. Oh, I shouldn't count actually, I think. Yeah, I should only count once, so maybe I can remove this. Let me see. Okay, list passes more tests. So now just these two here. So 1,000 should be. One should be only 1,000. But yeah, I don't think that's the way that it is supposed to work here. Score 1100 plus one for the other. So I think that maybe this test. Oh no, I'm getting 1,000 and I should be getting. Okay. Oh, it's because of the condition. Yeah, I have to make the if statement here. So if key equals to 1. Yeah, but then I'm gonna have the same problem. Plus equals value minus 3 times 100. And if key equals 5. I think it's 5. Maybe I confused the order here that time. Yeah, there we go. Nice. So I think this solution is better than the other one actually. But it's probably still not the best. Yeah, but I'm only using two loops now. So it's O n square, I think. The complexity. And I don't think I can use the product here because I only have one list. Unless I create another one and then I can use the product for if I create for the count or something like that. Or I can make another list of numbers from 1 to 6 and then use the product on the two lists. I'm making an if condition probably. Yeah, but then yeah, I think I'm gonna leave it like this and just look at the other people's solutions. Just gonna erase this stuff from here. Not sure if I'm gonna have time to do another one. I still have 1 hour left. And so this person created 4 lists. Probably, yeah, the same, very similar logic, I think. But they use the list comprehension here. So they are using the sum. They use the counter to count the values. So instead of objects, they are using lists, but the logic is the same, I think. I wonder which one is better. I think the only difference is the way that the memory is used. Probably lists are faster, actually. I'm not sure. Maybe dictionaries are faster, but lists use less memory. What is more efficient? Lists or dictionaries? I don't remember really well, but I think maybe objects are made with lists, I think. It's either one or the other, but I don't remember really well. I think objects are made from lists. It might be confusing. So dictionaries are simpler. Dictionaries is faster than a list. Okay. It's more efficient to use dictionaries for the lookup of elements as it is faster than a list and takes less time to traverse. Moreover, but I think dictionaries take more memory probably. Moreover, this keep the order of the elements while a dictionary does not. So it is wise to use a list data structure when you are concerned with the order of the data elements. Also, it is recommended to use a list data structure when dealing with the data values that might get changed in the future. It is because keys in the dictionary should be unique in nature and may cause problems while modifying them later. It is important to require very little space to store the data elements in comparison to lists. Okay, so it's both faster and less memory. I'm not gonna spend too much time reading this. So here they did the same thing with the counters, making plus equals 1 depending on the values of the lists. Then they made another list for the extra points. Then they loop through the counter and add through the sum based on the other list of counts. So it just gives the value if it is greater or equal than 3, else 0, plus extra I times count times the remainder. Very clever, this part here. Turn dice, count. I don't like this solution that much. It's kind of hard to understand what's going on. I think it's counting each element using this function. And then getting the remainder divided by 3 times 100 times 1000 times the number of points. And then for 1 and 5 is adding the extra points. Yeah, so nobody's using products. So I guess it's not the best application. Yeah, nothing really crazy here, I think. Now this seems very way too complicated. I thought this challenge was a lot easier than the other ones of the same level that I had so far. So I think it depends a lot on both the person. Sometimes the challenge can be easier for you and harder for someone else, and vice versa. And I'm not sure if I should do harder challenges because the ones that I try for 4Q, I spent a bunch of time trying to solve them, and I solved only one. I think I tried 2 or 3, solved only one, and the other ones I looked at the solution. Because they seem to be a lot harder than 5Q. Write a function that accepts a square matrix n times n to the array and returns the determinant of the matrix. How to take the determinant of a matrix? It is simple to start with the smallest case. Has a determinant A, H by 2. So I think a determinant is something that when transposed and multiplied gives the identity matrix, I think. I don't remember really well. But it's something like that. Square matrix. So I'm gonna receive a matrix. And I have to return the determinant. Oh, it's more complicated than that. Yeah, I remember now. Through this calculation here. You have to multiply and then subtract. If the matrix is bigger, then you have to cancel the elements line by line and multiply. It's very complicated actually. The determinant of an x n times n size matrix is calculated by reducing the problem to the calculation of the determinants of n matrices of n minus 1 times n minus 1 size. To reduce to the other level and calculate the determinant of each number is a times the determinant a minor. So the first thing that comes to mind is the recursive solution for this, because you're gonna have to break the problem, reduce the problem, and call the same function if the matrix is big. And the other thing that comes to mind is the Cartesian product stuff from ether tools. And just need to think if it makes sense to do that. I think if I can calculate the determinant using the product, I can just do that calculation and call a recursive function if the size is bigger than 2. The dimension of the matrix is bigger than 2. But the only issue is that I don't remember determinants very well. The determinant is where first taking the determinant of the 2 by 2 matrix created by crossing out the row and column in which the element A occurs. Note the alternation of signs. The determinant of larger matrices are calculated analogously, e.g. if M is a 4 by 4 matrix with first row. The determinant of M equals A times determinant of A minor and B minor. Hmm. And have to alternate the signs as well. I don't think I'm gonna do this now because it's probably gonna take me. I think I can solve this with enough time. It doesn't seem to be. The hardest part about this is figuring out the determinant equation. But I think the path to the solution is like I spoke before, where you just calculate the determinant and you call recursively and you put an if condition depending on the dimensions, you change the signs of the equation based on that. But if you solve each determinant, the smallest determinant, with the product, probably, and then you do recursively, you call recursively based on the dimensions of the matrix. And each time you reduce the dimensions until it gets to the lowest one. Yeah, but it's still very difficult though, because how you will get each one. I guess you can just make plus or minus. You can make an if else condition to alternate the sign and call recursively adding or subtracting each time. Yeah, but I'm not gonna do this now. I don't have time. I don't think I can solve this in 42 minutes. So I'm probably gonna come back tomorrow or some other time. And I think I'm gonna try to do for 1 hour and a half each day one of these. And if I can't do it, then look at the solution. And then with the rest of my time, I'm probably gonna try to do, not try to do it, I'm gonna do Kaggle competitions to practice data cleaning and data analysis to study for the tests, become better for the tests on Turing. So yeah, so see you then.